Yo guys, Tanmay for Simple Snippets back with another video tutorial on quantitative aptitude. So in this video tutorial, we are going to be covering the topic of problems on train. Now in the previous video tutorial, we saw some problems on time, distance and speed, and if you have missed that video, you might want to check that out because we would be requiring some concepts from that part, because in problems on train, we have concepts of time, distance and speed as well. So if you have missed that video, you can check that out and I'll put the link in the description of this video. Now problems on train are a very important topic in any general quantitative aptitude test, be it for college placements, be it for competitive exams and so on and so forth. You can expect about 2 or 3 questions based on train or time, distance and speed. So make sure you get a good heads up on this topic and make sure you have your concepts clear about this topic. So with that being said, let's get started. So before we actually start solving the numericals, let's see some important concepts about problems on train and let's see some formulas and some derivations. So as you can see on the screen, we have 2 basic formulas. Now here you can see that we have said a kilometer per hour is equal to a into 5/18 meter per second. So this is just a basic conversion between 2 units. So one is kilometer per hour, you can see over here, and if you have a value or speed which is a kilometer per hour, then in order to convert it into meter per second, you just have to multiply it by 5/18. So this kilometer per hour and meter per second are standard units for speed. And similarly, if you want to convert a speed value which is in meter per second, we just have to multiply it by the reciprocal of this 5/18, which is 18/5 kilometer per hour. So this is something just that you want to note it down and probably remember it, because it is very easy directly to apply the formula rather than actually trying to calculate and convert it manually. So just remember this formula because it would make your calculations fast as well. So let's move on to the third point. Okay, so let me just read out this point. So the time taken by a train of length x meters to pass a pole or a standing man or a signal post is equal to the time taken by the train to cover x meters. So let me just explain what this point is trying to explain us. So we have a train, you can see over here, which is of x meters, and then we have a person over here who is standing at this dotted line. Let me just draw a blue line over here. So this is where the person is standing, or you can consider this as a signal post or a lamp post or any pole. Now what this point is stating is, starting from this point over here, the time taken by the train to completely pass this line is equal to the time taken by the train to cover x meters. Because the length of the train is x meters, when the train is at point A, it is starting over here, and when it reaches over here, you can see at this point, it is completely past the person, which means that it has covered x meters. So this is exactly what this point is trying to state, and you can see it visually as well over here. So the time taken by a train of length x meters to pass a pole or a standing man or a signal post is equal to the time taken by the train to cover x meters. So I hope this point is clear to you now, and let's try to move on to the next point. Okay, so point number 4. The time taken by a train of length x meters to pass a stationary object of length b meters is the time taken by the train to cover x plus b meters. So similar to the first or the previous point, this point states that there is an object which has its own length. Now in the point number 3, we had a person or a pole, but here we have an object, say for example a house, whose length is b meters. You can see over here, and the train's length is x meters. So in order to completely pass this entire distance, the train has to cover x plus b meters. That means when the train is going to be at this point, it has passed x meters plus b meters. So that is what this point is trying to state, and it is stating that the time taken by the train of x meters to pass a stationary object of b meters is the total of those two lengths. So after passing this object, the train would have covered its own length as well as the length of that object. So that is why it is x plus b meters. And this is pretty clear from this visual representation as well. So this was point number 4. Let's move on to point number 5. Okay, so here's the point number 5. Suppose 2 trains or 2 objects, so in this case we are considering trains, are moving the same direction at u meter per second and v meter per second. So these are the speeds u and v respectively, where u is slightly greater than v, then the relative speed is u minus v meter per second. So both of the train are moving in the same direction, u and v, but if we compare their relative speeds, it would be u minus v. So if a person is inside this train and he is observing this train, he would see this train a little slow. That is because of the concept of relativity. Since both these trains are moving and there is a slight mismatch between their speeds, that difference is what the speed is observed by this person. Or if a person is inside this train and he is observing that train, he'll see that train moving only slightly faster than this train, even though it has a very high speed, but since even this train is moving in the same direction, he sees that train moving slowly ahead of this train since u is greater than v. And that slow motion can be derived by this equation, or you can say that the relative speed is u minus v meter per second. So make a note of this, and this is only when the train is moving in the same direction. Both the trains are moving in the same direction. So what happens when the train are moving in opposite direction? Let's try to see point number 6. Okay, so in point number 6, the trains are moving in opposite directions. There is a train 1 which is moving in this direction and this train 2 which is moving in this direction. So suppose two trains or two objects are moving in opposite direction, u with u meter per second and v meter per second, then their relative speed is u plus v meter per second. So if you are inside this train and observing this train, you'll see that this train moves very fast and just passes the train with a very high speed, which is actually the addition of these two speeds. And that is because even this train is moving in the opposite direction. So we see that the other object is moving very fast, which is faster than their actual speed. And that is because of the concept of relativity. So the relative speed is addition of these two speeds. So just make a note of this, and this is for when the trains or the two bodies are traveling in opposite directions. Now let's move on to the point number 7. So point number 7 states that if two trains of length a meter and b meter are moving in opposite directions, as you can see in the diagram, at speed u meter per second and v meter per second, then the time taken by the train to cross each other is equal to a plus b divided by u plus v seconds. Okay, so for this we need to understand the formula of time, distance and speed. So we know time is equal to distance upon speed. Okay, so in this case the trains are moving in opposite direction. So we know that relative speed is going to be u plus v. We just saw that in point number 5 or 6. You can go back and check it out. So we know that relative speed is going to be this. Now the distance is going to be the distance of this train plus distance of this train. So in this case we know the first train is a meters long and the second train is b meters long. So the time taken is going to be distance upon speed. So the total distance is a plus b and the speed is equal to u plus v. So now we can calculate time. So time is equal to a plus b upon u plus v. So this is exactly what we've just derived over here, and this is what this point is stating. So since the trains are moving in opposite direction, we have to take relative speed of both the trains, and of course the distance is going to be a plus b because the total distance that they will cover after they pass each other is going to be a meters plus b meters. So this is what point number 7 states. So let's move on to point number 8. So point number 8 states that if two trains of length a meters and b meters are moving in the same direction at u meter per second and v meter per second, then the time taken by the faster train to cross the slower train is equal to a plus b divided by u minus v seconds. So in the previous point we saw that the two trains were moving in opposite directions, but in this case the trains are moving in the same direction and one train is moving faster than the other. Let's consider that the first train, this one, is having higher speed, that is u meter per second, compared to this. So they are saying that the time taken by this train to overtake this train completely is going to be a plus b divided by u minus v seconds. So in point number 5 or 6 we saw relative speed is going to be u minus v if trains are traveling in the same direction, and the distance that they are going to cover is going to be both the lengths of that train. So if this is of a meters and this is of b meters, the train is going to cover a meter as well as b meter to completely pass this train from this point. So the distance is going to be a plus b meters. So now we can calculate time by using the formula time is equal to distance upon speed, which is going to be a plus b upon u minus v seconds. And since the distance is in meters and speed is in meter per second, that is the reason why the time is also in seconds. So this is another formula that you need to note down. Okay, so let's move on to the last point. So this is the last point. It states that if two trains or bodies start at the same time from point A and B towards each other, and after crossing they take A and B seconds in reaching B and A respectively, then A speed to B speed is equal to B speed to A speed. So they've given some ratio calculation, and let's see how they derived this. So we have train 1 and train 2. Train 1 is starting at point A and is going till point B, and it takes A seconds to reach point B. Then we have train 2 which starts at point B and it goes till A and it takes small b seconds to reach point A. So what they are saying is the speed of train A divided by speed of train B is going to be in ratio or is going to be proportional to the time taken by train 2 to reach point A divided by the time taken by train 1 to reach point B. Now if you have seen the previous video tutorial wherein we discussed the time, distance, speed concept and different problems, we know that speed is indirectly proportional to time. That is, if speed increases, then the time to cover a particular distance decreases. So let's say for example this distance is going to be x meters. So for train 1, we know that the distance it has to cover is x meters, time taken is a seconds. So they have mentioned that it takes a seconds to reach point B, which means it takes a seconds to cover x meters. So now the speed is equal to distance upon time, which is going to be x upon a meter per second. Similarly for train T2, we know the distance again it has to be x meters because train T2 is starting from here and it will stop till here, so it is going to cover x meters only. So we have x meters and the time it takes is going to be b seconds. So they have said that b seconds to reach point A. So for this the speed would be distance upon time, which is going to be x upon b. So if we take a ratio of these speeds, so if we see s1 upon s2, you can say that it is x upon a divided by x upon b. So we have x cancel and ultimately we are going to get this as the answer. So a speed upon b speed is equal to time taken by train 2 or train B to reach point A upon time taken by train 1 or train A to reach point B. So it's basically inverse. So this was the last point, and these are the few concepts that you need to know properly in order to solve these problems efficiently and quickly. So now let's actually start off with the problem solving, and we'll try to solve 5 different problems with different variations. So now let's see problem number 1. Let me just read out the question. A train is running at speed of 60 km per hour and crosses a pole in 9 seconds. What is the length of the train? So the options are in meters. So we have A 120, B 180, C 324 and D 150. So let's try to solve this problem. So we have a train. So let's say the length of the train is x meters and it is saying that it has a speed of 60 km per hour. So we'll say speed is equal to 60 km per hour. It is saying the time it takes to pass this pole is 9 seconds. So what exactly is happening is this train, as you can see, when it reaches point this or when it reaches the starting of the pole and when it completely passes this pole, the time elapsed is 9 seconds. So when it is completely passing this pole, it is covering a distance of x meters. So remember that we discussed in point 1 that the distance traveled by a train when it crosses a pole is its length itself. So the distance they've given us indirectly is going to be x meters because we just considered the distance of the length of the train to be x meters. And they've also given us the time, which is going to be 9 seconds. So we just need to find the distance in meters. So before that we need to convert this speed into meter per second. So we also have the formula which we saw in point number 1 and 2. So in order to convert kilometer per hour to meter per second, we have to use this formula and we have to multiply the value by 5 by 18. So speed is equal to 60 into 5 by 18 meter per second. And now we can calculate the distance. So the formula is going to be distance is equal to speed into time. Now we know distance is x meters that we've considered, which is equal to speed, which is 60 into 5 by 18, and the time is 9. So we know the time is 9 seconds. So we have 9 ones are 9 twos are 2 ones are 3 are 15. So x is going to be 150 meters. So the final answer is going to be x is equal to 150 meters. So this is the final answer. You can see we have option D as the final answer, and this x 150 meters is the actual length of the train that it had to cover when it passed the pole. So indirectly they've given us the length of the train, which we have to find out. Okay, so let's move on to the question number 2. Okay, so here's the question number 2, and let me just read out the question. So a train 125 meter long passes a man running at 5 km per hour in the same direction in which the train is going in 10 seconds. So the speed of the train is, and they have given us the options in kilometer per hour. So let's see what all details we have. We have a train and we have a man which are going in the same direction. The train is traveling at some speed which we will consider as x km per hour, and the man is traveling at 5 km per hour. Now they're saying that this train completely overtakes this man in 10 seconds, and they're asking for the speed of the train. So when the train completely overtakes this person, this train would have passed this person. So the last part of the train would be like this, something like this. So it would have covered distance which is equal to the length of the train. So here we know that the distance is going to be 125 meters, because when the train completely passes the man, it would have covered its own length as distance. So that is why the distance is going to be 125 meters. Now the time it takes to pass the man is 10 seconds and the speed of the train is asked. So speed 1 or speed x is question mark. But in the problem, this speed at which this train is overtaking this man is actually the relative speed, because both of them are traveling in the same direction. And we have seen in the 9 points that we just saw before actually moving on to the problem solving that when it comes to relative speed, if the two objects are moving in same direction, the relative speed is going to be u minus v. So in this case, it is going to be x minus 5. So this is the speed that they have given us. So the speed is x minus 5 and this speed is going to be in kilometer per hour. Now let's calculate this relative speed. So this relative speed, that is u minus v, is going to be distance upon time. So u minus v is x minus 5 is equal to, the distance is 125 meters upon time is 10, and since this is in kilometer per hour, we have to convert this meters and seconds into that same unit format. So we have to multiply it by 18 by 5. So ultimately we have x minus 5 is equal to, just cancel out these values and you'll finally get 45. So the relative speed is 45 km per hour. But we want to find out the speed of the train. So x is equal to 45 plus 5, which is going to be 50 km per hour. So this is our final answer. So in the option we have option B as the final answer. So I hope you understood how to calculate relative speed, and then from that we can calculate the individual speeds of the different objects. So now let's move on to question number 3. Okay, so here's the question. The length of the bridge which a train 130 meters long and traveling at 45 kilometers per hour can cross in 30 seconds is. So we know that the train which is 130 meters long, which is traveling at 45 kilometers per hour, takes 30 seconds to cross this bridge of x meters. So this is the ultimate position or the last position when the train would have crossed the entire bridge. So it would have covered its 130 meters plus this x meters of the bridge. So the distance is going to be 130 plus x meters that it is covering. Speed is going to be 45 km per hour and time is equal to 30 seconds. So we know distance is equal to speed into time. So let's just put all these values in the proper units, and we want the units in meter per second, and the answer is going to be in meters. So we'll convert the kilometer per hour in meter per second. So 130 plus x is equal to 45 into 5 by 18. So we need to multiply this 45 km per hour into 5 by 18 to convert it into meter per second, and the time is 30. So solving this, we will get 130 plus x upon 30 is equal to 25 by 2, which is again you're going to get 2 into 130 plus x is equal to 750. And ultimately solving this equation, we just need to open up these brackets, multiply the 2 by all these values, and then finally the answer is going to be x is equal to 245 meters. So this is going to be final answer. So let's move on to question number 4 now. Okay, so let me just read out the problem. Two trains running in opposite direction cross a man standing on the platform in 27 seconds and 17 seconds respectively, and they cross each other in 23 seconds. The ratio of their speeds is, and they've given some ratios. So train 1 takes 27 seconds to cross this man in this direction, and train 2 takes 17 seconds to cross this man who is standing on a platform in 17 seconds. And these two trains take 23 seconds to cross each other as well. So they want the ratio of their speeds actually. So they don't need a definite value, they just want to see the ratio of their speeds. So let's say speed of train 1 be x meter per second and speed of train 2 be y meter per second. So we are just assuming their speeds. Now the time taken by train 1 to cross this man is equal to 27 seconds, and time taken by train 2 to cross that man is 17 seconds. Now by the formula of distance, which is equal to speed into time, so distance 1, that is the distance traveled by train 1, is going to be this into this, that is speed into time. So we have 27 into x. Similarly distance 2 is going to be 17 into y. And this distance d1 is going to be the length of this train 1, and this distance d2 is going to be the length of train 2, because when train 1 passes this man completely, it covers its own length, and when train 2 passes this man in the opposite direction completely, it again covers its own length. So distance is going to be equal to the length of their respective trains. And lastly what they are saying is they cross each other in 23 seconds. So when the train 1 and train 2 completely cross each other, they would have totally covered a length equal to total length of their own distance. That is, when train 1 and train 2 crosses each other, they cover a distance of d1 plus d2, which is going to be 27x plus 17y. So the final distance, that is d total that they cover, is 27x plus 17y. and the time taken is equal to 23 seconds. So the time taken to completely cross each other by the train 1 and train 2, so T total is going to be 23 seconds. But now this is going to be relative speed. Thus relative speed is being considered because they are both traveling in opposite direction. So the speed which is going to be relative in nature is going to be equal to x plus y, because we considered speed of train 1 as x meter per second and speed of train 2 as y meter per second. So the final equation, that is total time taken to cross each other by train 1 and train 2, is equal to distance covered by both the trains, which is dt, upon speed, which is relative. So we know the total time taken by the two trains to cross each other is 23 seconds. So 23, which is equal to total distance covered, is going to be length of train 1 plus length of train 2 when they completely pass each other, which is going to be 27x plus 17y, and the relative speed is going to be x plus y because they are traveling in opposite directions. Now this is the equation that we need to form, and now we can go ahead and solve this to get the ratio. And the ratio is going to be between the two speeds. That is, we need to form an equation wherein we have x by y. So let's continue this over here. Now once we have this formed, this equation formed, we can then go ahead and simplify it. So we can say 27x plus 17y is equal to 23 into x plus y. Then ultimately when we solve this, we get 4x is equal to 6y, and lastly we can have x by y is equal to 6 by 4. So final answer is going to be x by y is going to be 3 by 2. So this is going to be our final answer. So in the options you can see option B is going to be our final answer. So the important part in this problem was to actually form this big equation from the given data. And since the trains are moving in opposite directions, their relative speed is going to be x plus y in this case, since we consider train 1 speed as x and trains 2 speed as y. So you need to understand relative speeds and normal speeds, and you need to understand when to apply which one. So now let's move on to the last question. Okay, so let me just read out the question number 5. A train passes a station platform in 36 seconds and a man standing on the platform in 20 seconds. If the speed of the train is 54 km per hour, what is the length of the platform? So we know the speed is 54 km per hour of the train. So let me just write it down over here. Speed is equal to 54 km per hour, which is going to be 54 into 5 by 18 meter per second. Since the answers are all in meters, let's convert the speed into meter per second and just keep it as it is. Now we need to calculate the length of this platform. So let's say this is B, length of the train is going to be A, and they are saying that the time taken for the train to pass this man is 20 seconds with this speed. So the distance is equal to speed into time. Now the distance it will cover when it crosses this man completely is going to be the length of the train itself. So A is equal to, now the speed is given as 54 into 5 by 18 and the time it takes is 20 seconds. So ultimately the length of the train DA is going to be 300 meters. So now we got one part of the problem because we got this as 300. Now we know the train's distance or length of the train is 300, but we have been asked the length of the platform. Now let's again read the question. So a train passes a station platform in 36 seconds. So let's see the formula for time. So time is equal to distance upon speed. Now let's again read this question. A train passes a station platform in 36 seconds. So we know the time taken by this train to completely cover this platform is 36 seconds. So I'll say 36 is equal to the distance it covers is going to be the length of the train plus length of the platform, which is equal to 300 plus B. Now this 300 came from this calculation itself, so we already know the distance or the length of the train is 300. So I substituted 300 over here, and the speed is also known to us because it is given that the speed is 54 km per hour. So just divide this by 54 into 5 by 18, and now we have got the equation. So as you can see, there is only one variable that we need to find out. So this is simple mathematical calculation, so I'm not going to go ahead and calculate everything. I'll just skip one or two intermediate steps. So then ultimately we will be left with B plus 300 is equal to 540, and then the final answer would be B is equal to 240 meters. So this is going to be our final answer, option B. Okay, so that's about it for problems on train, and we saw different concepts and some important points to remember. We saw some formulas and conversions. We saw what relative speeds and how to use them. So make sure you make a note of all those different points that we discussed before actually moving ahead to solve these problems. Then we solved 5 different variations of problems on train, and I hope you understood them. And if you have any queries, then you can always put them in the comment section. And if you want more more such problems based on trains or time, distance and speed, you can let me know in the comment section. So that's it for this video guys. I hope you understood the entire topic of problems on train, and let me know what you think about this video. So I'll talk to you guys in the next one, and if you like this video, give it a thumbs up, share it with your friends, and don't forget to subscribe to our channel. Peace.